In this video, we are going over 3 higher maths questions, one on logarithmic equations, another one on complex numbers, and a third one on sequences and series. This is a 4 marks question. Find the solution of the logarithmic equation log base 2 of x minus log base 2 of 5 equals 2 plus log base 2 of 3. You get 2 marks from your method and 2 marks from your answer. The first mark comes from collecting at least 2 log terms. Moving log base 2 of 3 to the left-hand side, you can write it as a single log base 2 of x over 15. The other 2 marks come from the answers. Rewriting the log statement in index form, x over 15 equals 2 squared, and the second from simplifying it, x equals 15 times 4 or 60. This is a 6 marks question. Write down the modulus and the argument of the complex number w and find the smallest possible integer n so that w to the n is a real number. We write z1 equals 1 plus I square root of 3 in polar form. For that, we draw the complex number and we calculate the modulus and the argument. The modulus, remember, is the distance from the origin and is found using Pythagoras. Yes, the square root of 1 square plus square root of 3 square equals 2. Check it out with your calculator. The argument is the angle in anti-clockwise direction from the positive x-axis. Using trigonometry, the angle theta is the inverse tangent of the square root of 3 over 1. In radians, this is pi over 3. We repeat with z2, 1 plus I. We draw the complex number and we calculate the modulus and the argument. The modulus is the square root of 1 square plus 1 square, which equals square root of 2. And the argument is the inverse tangent of 1 over 1. In radians, this is pi over 4. It's an angle of 45 degrees. The correct way to write it in modulus argument form is shown here, and you will miss 1 mark for not writing this correctly. Now with w. W is the quotient between z1 and z2. Using the movers, we divide the modulus and we subtract the argument. 2 divided by the square root of 2 is the square root of 2, and pi over 3 minus pi over 4 is pi over 12. Now with part B, we need to find the smallest possible integer n, the smallest possible, so that w to the n is a real number. For a complex number to be real, the argument has to be either 0 or pi. 0 will lead to the solution n equals 0, which is not allowed. We are told that n is positive. So the argument must be pi, because we are looking for the smallest value of n. So if n pi over 12 is pi, then n is 12. This is a 7 marks question. An arithmetic sequence has first term 1. If the second, the third, and the sixth terms of this arithmetic sequence are the first 3 terms of a geometric sequence, we need to find the common difference, d. For the second part, we need to find the sum of the terms in this arithmetic sequence from 1 to negative 15. The second term of the arithmetic sequence is 1 plus the difference. The third term is 1 plus 2 differences, and the sixth term is 1 plus 5 differences. Now, pay attention. This is a trick that you may or not know. Since the 3 are consecutive terms of a geometric sequence, we can say that the first term of a geometric times the third term of this geometric equals the second times the second, or the second square. We expand both sides of the equation. This leads to the quadratic d squared plus 2d equals 0. We factorize and we solve for d. Since the common difference cannot be 0, because this would not generate an arithmetic sequence, d must be negative 2. You can check that your answer is correct. So the sequence with difference negative 2 that starts with 1 goes 1, negative 1, negative 3, negative 5, negative 7, negative 9. The second, the third, and the sixth, negative 1, negative 3, negative 9, form a geometric sequence with common ratio 3. The arithmetic sequence has first term 1 and common difference negative 2, so the general term is 1 plus n minus 1 times negative 2. If that equals negative 15, then solving n equals 9. So we need to add the first 9 terms of our arithmetic sequence. And this can be quickly evaluated using the formula. The first term plus the 9th term times 9 over 2. This is negative 63.